Universal Time.
I am in radio contact.
Today in the lab, it is the Hewlett Packard 8711B Vector Network Analyzer. This particular unit is the 75 ohm model. So today we will be converting it from 75 ohm impedance to 50 ohm. With the front panel off, we can see the receiver module, which needs modification. Looks like we have to remove some semi-flexible jumpers, and they actually put an eject handle in for the receiver module. Quite nice. Some screws have to be removed as well. It looks like we have to take the rear panel nut of the BNC connector. This is the aux input. Alright, get the SMA connectors off now. With the jumpers off, this eject lever should work, and it does. Well, damn. With the module out, it is quite the dusty one. I'm probably actually going to have to take this outside with the paintbrush and brush it off. But, yeah. I've never seen anything this dirty. Okay, so the first step in converting the 75 ohm receiver to a 50 ohm model is replacing the front panel connectors here and here. These are actually 75 ohm end connectors, as evident by the center pin being slightly smaller than a normal 50 ohm end connector. So I do have some 50 ohm replacement connectors that I got off of eBay. But I do have two different types, so I'm not sure if I can use both of these, and I might actually have to get another one so I have a good matched pair. Also of note is this piece of semi-rigid is 75 ohms, and the connector it's feeding into back here is 75 ohms as well, and will be needing replacement. Okay, so you can see on this port how the center pin is clearly smaller, so that is a 75 ohm N to SMA adapter. And rumor has it the port that's on this side is 50 ohm input and then has an in-series 25 ohm resistor to go from 50 to 75 ohm. So we'll take a quick measurement and see if that's actually true or not. And in fact, the rumors are true. It does have a 25 ohm in-series resistor. Alright, we are back and we are clean. So the paintbrush wouldn't do it. I actually had to bust out an air compressor to get this bad boy clean, and boy howdy. Like I said, that's probably the most dust I've ever seen in something. I've also removed the RF shielding from this section so we can see a little bit more about what needs to be replaced. So the big magic that happens inside of these is these mini circuits 20 dB directional couplers. So right now the unit has the 75 ohm version in it, and I did check with mini circuits, and they will sell you the 50 ohm. Unfortunately, they are $70 each, and you have to order 10 of them. So hopefully we can modify that. So I'm thinking what is in there is a transformer and a load resistor that's probably 75 ohms. So with a little bit of luck, we can probably change that for a 50 ohm if we can get inside the can. Also, this is a 75 ohm SMA connector that needs replacing, and there is a handful of resistors that need replacing on the board as well. This is a resistance soldering iron. The pinchers are made out of low resistance carbon, and we're going to be putting low voltage, high current AC into the part itself to heat it up. You do got some movement. Come on. There we go. Alright, now we can clean out the hole with the solder sucker. And I have a new Amphenol SMA connector that hopefully the center pin is the right diameter for this hole. Sure make it hard to get out of the package. No, looks like it might be just a skosh too big. Alright, it's Dremel to the rescue. So it turns out that the center pin that is on the board is actually for the 75 ohm SMA connector, and the center pin on our new connector won't actually fit, so I'm going to have to Dremel it down a little bit. Alright, looks like we got a pretty good fit. Alright, next up on the list, we have to replace a couple of 90.9 ohm resistors. Let's see, one is located here, and the other is located here. And we are going to replace those for 56.2 ohm, 1%, and it looks like they are 1206 parts. Alright, so while I have these resistors out, I'm going to take a measurement here with the meter, because theoretically there should be a 75 ohm resistor on the other end of the coupled port, but I am reading like 1.1 ohms on the meter, so that tells me that is not the case. So as a result, I will not be slicing into the directional couplers. I was hoping there was a resistor in there we could change to change the impedance from 75 to 50 ohms, but as it turns out, there is not. So the next thing to change is the ID bits of the receiver card, and that is done on U60. So on the 75 ohm card, pin 6 is high, and pins 7, 8, and 9 are tied low. So we have to lift up pins 6 and 7, and we are going to ground 6 and then put plus 5 on pin 7. Alright, I've made up some 30 gauge Kynar jumpers, and we'll see if we can get them attached here. Sorry if I get in the way. Okay, that's looking pretty good. And what did I say? We want this pin to go to +5. So we can just get that at the top here. Okay. And the other pin will just come down to ground over here. Alright, looks good. Now we can put the shielding back on. Alright, we have our new 50 ohm end connectors installed on the front panel, and while you weren't looking, I took the time to make a new jumper from the port 1 connector back to the connector on the board. I just used some scrap semi-flex, I believe it's 0.141 inch diameter, and I salvaged the rings, these coupling rings, off of another piece of semi-flex that was only like 2 or 3 inches. So I salvaged those off and soldered them to the new jumper here, and so I'm a little bit off, but you know, it should we should be able to bend it a little bit and make it fit. And with a little bit of finesse, our new piece of semi-rigid is in. Alright, I just did a quick stick it back together to see how we did. I'll take it apart again later to do a thorough deep clean, but let's check it out. Okay. Looks like we're in business. Notice it doesn't have the 75 ohm option displayed anymore, so the receiver bits must have changed that. Then again, I never turned it on once I got it, so okay, so this thing's totally new to me, but yeah, here's what a piece of coax looks like. I still have to calibrate it, but we are getting useful measurements out of the unit. Give me a second here. So I just grabbed a random filter I have on the bench. We got a TX RX 163 to 173. I'll plug that in and see what it does. So kind of not doing too good. Looks like it needs a tune, but yeah, it's making measurements, and yeah. Well, as always, thank you for your time, and try to enjoy yourselves the rest of the day.